So we have a kite given, ABCD. This is a kite with AB is equal to BC, okay, one pair of congruent sides, and CD being congruent to DA, another pair of congruent sides. And this is essentially what makes this quadrilateral a kite. So now we're given that EFGH serve as the midpoints of AB, BC, CD, and DA, right? So the midpoints of all kite sides are these points, H, G, F, E. Okay, so now we have to show that EFGH is a rectangle. So the easiest way to do that would be to show that there are four interior right angles. So basically we have to show that HG is perpendicular to HE, and etc, etc. So every pair of adjacent sides is mutually perpendicular. Okay, so we have to show that. So the first thing to do is to copy down the given statement. We've copied down everything that was given. The next step is to see that DB and AC are diagonals of a kite. Okay, so these are the diagonals. So we're gonna say DB and AC are diagonals. So the reason for that is simply definition of a diagonal of a kite. Now the next part is to see that these sides of this quadrilateral in question, these sides are actually mid-segments. Okay, so HE is a mid-segment of triangle ADB. So if you can find triangle ADB, this diagonal of the kite will serve as the third side of this triangle ADB. Okay? So HE is the mid-segment of this triangle ADB. So similarly, there will be three additional mid-segments because there will be three triangles. One triangle, the second triangle, ADC triangle, the third triangle, DCB triangle, and then finally, triangle ABC. So each will have its respective mid-segment, right? So we need three more. So we will have a GF mid-segment, quotation marks, because this means the same thing, of triangle what? Let's see. So GF is this one. So we're talking about triangle CDB. Okay. Now the next one will be HG is a mid-segment of triangle what? So let's find HG, right? So the mid-segment of triangle ACD. And finally, the last mid-segment is EF. Is a mid-segment of triangle, let's find that. So EF is right here, so we're talking about this triangle. ABC. So the reason for this is the definition of a mid-segment. So basically the definition would be to note that mid-segment connects the midpoints of adjacent sides. Right? So notice that AD is adjacent to AB. So each side, each of these adjacent sides has a midpoint, and if you connect these midpoints, you will get a mid-segment, right? That's what mid-segment is. And also mid-segment happens to be parallel to the third side of the triangle. That's another property that we're going to use in this proof. Okay, so this is the definition of a mid-segment. So now the fourth statement is to realize that AC is perpendicular to DB, and that's a fact that you should know, right? So we're talking about the diagonals of a kite. they must be perpendicular. That's a property of a kite. All right, so we can say diagonals of a kite are perpendicular. Okay, so this is a property of a kite. Its diagonals must be perpendicular. So now the next step is to see that HE, right? So we're talking about mid-segments now. HE will be parallel to DB. So as we've noted before, each mid-segment is parallel to the third side of the triangle that it represents, right? So mid-segment HE represents triangle ADB, right? ADB. So it must be parallel to side DB, right? So HE is parallel to DB. So we're going to say HE is parallel to DB. Okay, and we will have 3 more such parallel statements like this, right? So there are 4 mid-segments, so we will have 4 of these. The next one is EF. Well, actually, let's use GF. Let's go with the next one, the opposite one. Let's go with GF. GF is parallel to, so this segment represents triangle what? CDB, right? CDB. So it's parallel to this side, the third side of the triangle, to DB, right? DB. Next one we have HG, this one. This mid-segment is parallel to the third side, and this represents triangle ACD, right? So it's parallel to AC side. AC. And finally, the last one is EF. EF must be parallel to the third side of this triangle ABC, which is AC. Okay, so the reason for that is simply mid-segment is parallel to the third side of a triangle. That's the simple reason. Now the sixth line. Now we're going to use transitive property of perpendicular lines. And how would we do that? Notice that AC is perpendicular to DB, but DB is parallel to HE. So by using the transitive property of perpendicular lines, AC must be also perpendicular to HE, because HE is parallel to DB, right? So we kind of pass it on. We let go of DB, and HE will take its place, right? So we're going to say AC is perpendicular to HE. Okay, now as you can see, there will be 3 more like that, 3 more substitutions in this case that we're going to use. So now notice that GF is parallel to DB. Now DB can be again crossed out, so that means AC is perpendicular to GF as a result, right? AC and GF. DBs are cancelled. So AC is perpendicular to GF. Now the next one, HG is parallel to AC, but AC is perpendicular to DB, so that means DB is perpendicular to HG, right? So we're going to say HG is perpendicular to DB. Any order is fine, right? You can use commutative property of perpendicularity. It's not going to affect the answer, because perpendicular is still perpendicular. You can go left or right, it's not going to change. Now finally, EF is parallel to AC, but AC is perpendicular to DB, so that means EF is also perpendicular to DB, right? So EF is perpendicular to DB. Okay, so now again, the reason for that is the transitive property of perpendicular lines. Now the next part is, so notice that we were talking about making sure that we arrive at conclusions that each pair of adjacent sides in this quadrilateral is perpendicular, right? So we're getting there. We need to show GH is perpendicular to HE, right? We need to show that. So notice first of all, we could use these two lines and use the transitive property of perpendicular lines one more time to make a substitution. Okay, so what I'm talking about is, notice that DB is perpendicular to HG, but DB is also parallel to HE, right? So that means we can make a substitution. We can let go of the DB here and set HG being perpendicular to HE, right? So HG is perpendicular to HE. Beautiful. Let's check that graphically. HG, HE. Beautiful. That's what we wanted, right? Two adjacent sides being perpendicular. Good. So we need three more pairs to finish this line. Now we need, let's see. We need HE being perpendicular to EF. How do we find that? So HE being perpendicular to EF. So notice that HE here is perpendicular to AC, but AC is also parallel to EF. So that means AC, we can let it go and set HE being perpendicular to EF, right? By using the transitive property of perpendicular lines. Beautiful. So HE becomes perpendicular to EF. Good. Now we need EF being perpendicular to GF, right? EF being perpendicular to GF. So let's see. So EF here is perpendicular to DB, but DB is parallel to GF. So that means we can let go of the DB and EF will be perpendicular to GF. Beautiful. EF is perpendicular to GF. Just what we wanted. And now the last part is GF perpendicular to HG. So let's see. So GF here is perpendicular to AC, but AC is also parallel to HG. So that means GF is perpendicular to HG using the transitive property. Right? Checking that again. GF perpendicular to HG. Beautiful. So the reason for this is the same as in line 6, transitive property of perpendicular lines. So now we're getting closer and closer. So what does that say? Since we already showed perpendicularity of adjacent sides, we can safely say that these angles are right angles, right? So what I mean is HGF, GFE, FEH, and EHG are right angles. Okay? And the reason for this is simply the definition of a right angle. Definition of a right angle basically states that when you have two perpendicular lines that intersect each other, you will form a 90-degree angle, which is going to be a right angle. That's the definition of a right angle. Okay? You must have intersecting perpendicular lines, and that's exactly what we showed in statement 7. Okay? We showed that each pair of adjacent sides was perpendicular to each other. So now that we showed that all these four interior angles are right angles, that's already enough to conclude that EFGH is a rectangle. And the simple reason for that is a quadrilateral with four interior right angles. Okay, so this is it. Hope you enjoyed it and it was helpful. Thanks for watching and see you in the next video.